Hi, so we will start to discuss the problem solving regarding the sequential circuit. Okay, I have an example here where there are binary numbers inside the circle and they will go to a different circle or the same circle with respect to the condition. So some of you might be familiar with this, but we'll go back to this. For example, this one. We start with 0, 0. Then, if the line is solid, that means 0, 0, 0. So you have three variables. Then the output will be how many? Two variables. So that is 0, 0 will become 1, 1. Then if that is 0, 0, 1, we'll go to the broken line, it will become 1, 0. Then if that is 0, 1, 0, it will stay at 0, 1. 0, 1, 1, it turn off, 0, 0. And 1, 0, 0, it becomes 0, 1. And 1, 0, 1, it will become 1, 1. 1, 1, 0 become 1, 0. And 1, 1, 1 will become 1, 1. So here is the truth table. Okay, I will zoom you out for you to see the sequence. Okay, if this is an example of sequential, but there's no condition yet if you're going to use flip-flop. Kasi if you're going to use flip-flop, that's different condition. I plot here 0, 0, then assuming the inside is AB, then the clock is C. So the result will be YZ. So if that is 0, 0, 0, that will go to 1, 1. If that is 0, 0, 1, turn on the clock, it will become 1, 0. Then if that is 0, 1, 0, remain 0, 1. If the 0, 1, 1, it will become 0, 0. If 1, 0, 0, it is 0, 1, 1, 0 rather. Then if 1, 0, 1, it will become 1, 1. 1, 1, 0, it will be 1, 0. And 1, 1, 1 will be 1, 1. So, upon putting here the K-map, the final answer of the equation is y is equal to a plus b bar. Okay. Then, this one, z will be what? A c plus a bar c bar. Okay. Okay. So, I'll show you what will happen in the logic loop. Here is the K-map of the equation where y is equal to, this will be A, B, and C. C is, I turn it into a clock. A plus B bar, then our Z is A bar, C bar, and A plus A, C. Okay, so here will be the behavior of 0, 0, 0, 0. The output will be 1, 1, and 1, 0. As you can see, the the y and z, the z are alternating with 1, 1 and 1, 0. If that becomes 0, 1, that will be alternating with 0, 1 and 0, 0. If that becomes 1, 0, it will be 1, 0 and 1, 1. If that is 1, 1, it will be 1, 0, 1, 1. So that is the example of sequence. Okay, we can change one variable depende dun sa pinupuntahan nung if the clock is on or off. I give you another example of sequencing. So, as you can remember, this is an example. This was your preliminary examination related to this, the train stations, the train stations that will pass from 0 to 2 to 4 to 5 to 6, 8, and back to 0. So here is a truth table where I plotted that the inputs will be A, B, C, D, and the output will be X, W, X, Y, Z. So as you can see, if that is 0, it will go to number 2. If that is 1, no output. 2 will go to 4. If 3, no output. 4 will be 5. 5 will be 6. 6 will be 8. 7 will be 0. And 8 will be 0. So, it'll go to 0. Okay. The meaning, the unshaded part, the train station will not pass through that. Now, here is the K-map. I'll just map this. This is at 6. There's a 1. Oh, it's wrong. So, it should be where? It should be here. And this would be 6. A bar, B, C, D bar. So, W should be A bar, B, C, D bar. Then, as you can see, X should be 2, 4, and 5. So, that will have the equation A bar, B bar, C, D bar plus A bar, B, C bar. Then, Y is 0 and 5. So, as you can see, A bar, B bar, C bar, D bar, A bar, B, C bar, D. And Z is 1 only for number 4. A bar, B, C, D. A bar, B, C bar, D bar. So, that will be A bar number 4. And but I will put here different color indicating that this will be the letter Z. Given the equations, See here, I have here the equations where W will be A bar, B, C, D bar. So it should open at 6. Then we have for letter X, we have A bar B C bar plus A bar B bar C D. Okay, so I regroup them so that I can use minimum input gates. I have branched out other things, other groups. Then I have A bar, this is B bar, and A bar, and C, D. So that will be the letter X. For letter Y, we'll have A bar, B bar, C bar, D bar, and A bar, B, C bar, D as regroup. And last for letter Z, it should be A bar, B, A bar, B, C bar, D bar. As you can see, I regroup it so there are few things that you can branch out. Using two inputs only, there will be 19. Two inputs instead of using 6 for inputs and two, two inputs OR. So we still have two inputs OR. So we'll check. At 0, it should go to 2. At 1, it should be out. So let's make it slow. Okay? 0, go to 2. Then 1, it will turn off. If that is 1, it should be turned off. If 2, it should go to 4. If that is 4, should 5, then 5 should go to 6. So you can see the output are 5 and 6. And if that is 7, 6 and 7, 6 will go to 8, then 7 is 0, then the rest will be 0. So this will be the circuit for that equation that I will put it here. So for your reference, so if I say that this will be minimum inputs, and if that is the minimum number of gates, then you have, regardless of the inputs, it will be like this.
Here now is the comparison of the basic gates on the left side and minimum gates on the right side. 19 gates for the left side and 8 gates for the right side. Let's now proceed to simulation of these basic gates and the multiple input gates. If that is 0, it should go to number 2. If that is 1, should remain 0. If that is 2, it should go to 4 and 3 should be 0. The same lang sila even if it's basic or multiple. If that is 4, it should go to 5 and it's 5, it should go to 6. Okay? Now, as you can see, tama yung pagkakailaw niya. Now, when you go to 7, 6 and 7, 6 should go to 8 and 7 should remain to 0. And 8 onwards will remain 0 kasi that is the sequence na ating hinahanap.